Well, good morning, everybody. Welcome to the first MOM in the Philippines. Thank you for coming today for this wonderful event. And I would like to welcome our foreign guest, the staff of MikroTik Latvia, and the guest speaker from other countries. My name is Dan Santillan of Cygnal Tech Trading and Services. Now, I don't want to waste my 30 minutes presentation, so I'll just go ahead with this. Now, augmenting multiple router board for port expansion by using VLAN. Now, the title seems to be a bit scary and complicated, but believe me, it will take a few steps on how to accomplish this. I apologize if I could not come up with an easier word to better describe how we expand the port. MikroTik is so flexible and so scalable. It is also powerful that your only imagination is the limit will ever have. Now, with the MikroTik, it won't limit you to the number of ports you can have and used for your LAN or for your WAN. Now, in order to understand the use of expanding the port, first, we must understand the problem or the obstacle of the internet here in the Philippines and why the number of WAN is very important here in the Philippines. Now, these are the common problems and obstacle of having a fast internet in the Philippines, and that is the reason why the WAN is so important and the most sought after functions of end user for looking for from a router. Now, according to a CNDNI study, internet in the Philippines has an average speed of 3.6 megabits per second, and that is true, okay? And fiber is not widely available even in the big cities, even in Makati, or even in the business district areas. Now, DSL is the most widely used medium of connectivity, and it has a maximum top speed of 10 Mbps in areas where DSLAM has a better copper wires and good contention ratio per user. Now, mostly, DSL, LTE, and fiber are capped somewhere between 2 to 10 GB a day. Huh? Okay. Now, for a fiber connection of 8 Mbps, it's so expensive, $75 per month with the capping. And simply, we just have a poor internet infrastructure, that's all. Right? Do you agree? Okay. Now, who can benefit from this topic? Organization who requires high download capacity, but no any other means of getting a fast internet, such as the fiber connections, but to use multiple DSL, especially in provinces where fiber connection is non-existent. Internet cafe operators without access to high-speed fiber line, WISP and mini ISP. We have Data Bytes Computer Services here, owned by Mr. Louis Datahan of General Santos City. Where's Louis? Louis? Okay. Now, even individuals who simply want hundreds of Mbps. Now, the top 6 most questions about the router's functionality is how many WAN it can support. Now, this is the question I always get from the potential client. Is the number of WANs. Most of the available off-the-shelf multi-WAN products on the market has a limited between 2 to 4 WANs only. And there are some other ones out there, like the Peplink, which is, they offer 13 WANs per router, and it costs thousands of dollars. The cheapest that you could find is somewhere around $7,000 for 13 ones. So it is very cost prohibitive for a small business owner. Now, one of my friends came to me and he asked me if I could help an internet operator with thousands of terminals in a single network. And the number of pieces ranges from, I think, 3,000 plus terminals on a single network. Now, this is the case study. This is the design, and by looking at it, it is very apparent to see the common problems. You have 3 routers, router 1, 2, and 3. Each router has 13 DSL, and another router with a 13 DSL, and another one. Now, the problem with this configuration, one set of computer or group of computer must go through one router. Okay? There is no failover with this. Now, the bandwidth is not fully utilized. What do I mean by that? First, if there are not much user on the group 1, the bandwidth on the first router is underused, while the other routers are at peak usage. So that is one of the problems of having this kind of setup. Now, so you have 3 routers to maintain. Firewall mangle rules must be identical to all routers to maintain uniformity. Now, what do I mean by this? Since all these 3,000 terminals uses the same program, gaming, all the applications, it's very logical to think that each router must have the same rules, same bandwidth management. So if you add, let's say you add a new game or a new application which requires one bandwidth management, then you have to put them all together on 3 routers, which is very hard to maintain. And then you have this multiple gateway problem. If one router goes down, then you have to change the gateway of one group of computers to use another router. But that will congest the other routers. So this is the problem of having multiple routers. And underutilized bandwidth. And of course, the price. It's very expensive. 7,559 for one router only. Multiply by 3, and that's somewhere about what? 24,000. Now, my client asked me if I can do this. Consolidate all DSL into one router to have a single point of operation. All firewall, filter, mangle rules must be in one place for easy operation and uniformity. In other words, if I want to add a single rule or a single set of bandwidth, I don't have to deal with 3 routers. I only need to deal with one, and that will affect all of the DSL. And we also need to utilize and optimize the use of all available bandwidth from all sources. And lastly, single gateway only. Right? All right. Now, let me ask the audience, how many of you uses 5 DSL or more? Nobody? How many of you are internet operators? A lot? And how many of you uses fiber connections? All right. Now, this is the typical deployment of a 3 router, 3 subnet segments in a single gateway. Now, what we need to achieve here is to have one gateway, but the problem with this typical deployment, you have to maintain 3 routers. The first router will give you the single gateway attached to the 2 other routers. The problem with this is you don't have full control of the modem and the bandwidth on the first router. And if one of those DSLs went dead, you don't have any control where the data will go through. So that is the problem of 3 routers and 3 subnet segments. There is no single point of operation, difficult to maintain, and it's very costly. Now, this is another typical deployment, which I'm sure you're familiar with. So you have 2 routers, 2 segments, and 2 gateways. Again, here is the problem of not utilizing all the bandwidth. If one group of computers, if it goes to router 1, and if that router goes dead, then you have to change the gateway of the whole segment to use the other router. Or if that group of computer is not used, you are just wasting the bandwidth, sitting there idly, right? Now, what we want is this. This is what we want. Single gateway, all DSL connected to the routers. You have a single point of operation, and then you can fully utilize the bandwidth, easy to maintain, full control of each DSL line, and many failover lines. So now you have 1 routers and a single subnet segment. Now, 23 WANs can be done with the router board CSR model. The question is, can it handle the task? Well, in a multi-WAN setup, each WAN must have at least 3 basic mangle rules for input, output, and forward chains to properly forward the packets to the right interface. So, if you have 23 WANs times 3 basic mangle rules, you have 69 mangle rules already, excluding mangle rules for other purposes. So if you have like one application like HTTP and you have 3 rules for that particular HTTP, you have to multiply it to your 23 WANs plus the 69 mangle rules. So now you will end up with 100 plus mangle rules and possibly hundreds of filter rules and layer 7 matching, QoS rules, Q3 simple queues, and here, why CRS is not viable for this? The answer is it has a low processing power for many WANs between 400 to 600 megahertz, and it cannot handle many mangle rules and filter rules for many WANs. And of course, CRS is designed for SOHO only. Now, where are the MikroTik people here? Would it be nice if we have this? Are they listening right now? Where's the MikroTik people? Okay. I just wish that they produce a multi-core high-end cloud router with more than 24 ports or some kind of an add-on module for port expansions. Makes life easier, really. Now, how can we have more ports for our WAN? Well, MikroTik doesn't have any powerful models with many ports, so what is the solution? The solution is to use the VLAN to expand the ports. Now, let me discuss the VLAN. When you hear, when somebody hear VLAN, what is the first thing that comes to your mind? What is the first thing that comes to your mind? This comes to your mind. Am I correct? That VLAN ports can only be used to join computers from other segments and only for client computers. Am I correct? What we can actually use it for? VLAN ports can be used as an ordinary physical port. So you got to treat it as such, but of course with some limitations. VLAN port can be used to connect other devices, such as the modems, DSL modems, cable modems, IP printers, IP cameras, and a lot more. Now, the VLAN ports on the MikroTik can also be used as a DHCP client, as if you have a router. And you can also use it as your routing interface. Now, the solution to use VLAN to expand the port is to use a fast router board, well, preferably dual core like the RB1100 or the CCR series, and use a lower cost router board such as the CRS 125 or the RB2011 or the RB951, just to augment it to expand the port. And you can also use a managed switch with VLAN capability. Now, the reason that I don't use third-party switch which can support VLAN because of compatibility issues, because I've tried different managed switch with a VLAN and it doesn't work well with MikroTik. Either you lose the packet, you don't have the control over the VLAN. So to get all the uniformity, I'll just use MikroTik. Now, this is what we should have, okay? So we use SFP port here connected to SFP port there. So that is going to be our trunk line or the trunk port to use the port on the CRS added to our CCR. So now you can have 43 ports available. Now you can expand it more if you want. As long as you have the money to buy the RB, then you can, just keep adding it. Now, this is the actual deployment of the Internet Cafe that I just configured a few months ago. So you have the CCR master, and then you have the slave, and then another SFP cable connected to the RB2011, the one that you can see down there. The one on the top, they are all fiber modems. The one that is connected directly to the master are all DSL modems. And the one on the RB2011 are also DSL modems. So each modems is 10 megabits each. So counting them like 2, 4, 6, 11, that is 110 right there. So you have somewhere between 350 to 400 megabits per second. Now, here is the configuration. I know this is what you want, right? Okay. Now, things we need. Cloud Core Router 1009. You could use the 1S or the cheap one, the 8G-1S only. And you need the RB2011 only for this demonstration only, okay? Then you can use the DAC cable, which is a 1 gigabit. And if you have plenty of money, you can get those. They're quite expensive, but it's fiber. And we like fiber. Now, doing this, that will provide you 17 ports already. Okay? Because we need to take one Ethernet port from the CCR to be connected to our switch. So you have, that is 8 port, that is 7 and 8, that is 17 ports. Now here's a configuration guide. We'll use the SFP port as the trunk port, and then on the slave, we do the same thing. Okay? We create a VLAN on the interface port and bind it to the trunk port. The same thing with the slave. Now, there's a difference with the configuration between the two on step 3. We will use the VLAN port as DHCP client, as if it requests an IP from your ISP, and create a NAT rules. On the other side, you have to create a bridge interface, and you bridge the VLAN port and the physical port. Now, it's very easy to add VLAN interface with unique ID. This is what the things that you need to do. You see the interface down there? You have to select the SFP port as your trunk port. Okay? And don't forget to use a VLAN ID. It has to be a unique. But in this case, I will just use 1, 2, 3, 4, 5, 6 in corresponding to the number of your actual physical port on the RB. And then you create a DHCP client using the VLAN, okay? And and you just have to add the default route again by counting 1, 2, 3, 4, 5, and 6. So that will give you the metric. And then you add the VLAN interface to firewall NAT, just like what you would do with a regular physical interface. Again, VLAN port must be treated like a physical interface. That's what you have to remember. So whatever you do with the physical port on your router board, you will do the same thing with your VLAN port. Okay? Now, on the client side, the same thing. However, you have to match the VLAN ID of your slave to your master. In other words, if there is a port 1 on your slave will correspond to VLAN ID 1 to your master and to your slave. They have to be matched. And then you will create the bridge port, the bridge interface. After doing that, as you can see, from the Ethernet, the interface is the physical port, bridged to bridge 1 port, and the VLAN 1 bridged to the same bridge interface. To give you a better idea, this is what it should look like. Okay? Are you with me so far? All right. Now, managing the bandwidth. We're done with the configuration. That's all you need to know. Okay? It's very easy. It's very simple. You can try this at home. So if you have 2 router board, you can actually try this at home. Managing the bandwidth. Now, I chose CCR model not because of its processing power to process billions of packets of data. Instead, I use the CCR port because of the mangle rules that I need to use. Now, here is the standard load balancing implementation. This is what is on the MikroTik wiki. Okay, the policy routing, DSL1 and DSL2, and your client. So you select a certain application and you want to push it to DSL1, and then the rest to DSL2. This one is okay. This one will work okay if you only have 2 DSLs. The problem arises when you have 23 DSL. Now you don't know which application goes where, right? You just simply do not know. Now, even if you do know, here is another problem. Not all computers will use that particular application. So you're just wasting the bandwidth of that particular DSL. So this is not an option to load balance. Now, of course, with the standard PCC, we have 8 and 5 Mbps. You add them all up, you get 13, right? Here's the problem. Because of the nature of the PCC's hash algorithm, the smaller line, the 5 Mbps, tends to get full. And then the big one is underutilized. So now you ended up with a bottleneck, okay? So the smaller line gets full, the bigger line is underutilized, and that will cause a lot of slowdowns on your network. Now, this is a PCC with per interface shaping and dynamic distribution. Now, if you will look at it, DSL1 with the 5 Mbps, DSL2 with 8 Mbps. Now, if you have an application that uses the DSL1, it will use up all your 5 Mbps. However, if you consume that 5 Mbps and if the application is too important, it has to take bandwidth from the second DSL line. Okay? And once the requirement is done, completed, the DSL2 must the DSL1 must return the bandwidth to the DSL2. So now you have this dynamic distribution. You need more, get it from one DSL. You're done, and then you just have to return it back, right? Did you understand it? Okay. Now this is what, in some cases, I use this, especially if the client requires a particular application to have a higher bandwidth. Okay. Now, PCC per interface shaping and equal load distribution. This is what I always use. Okay? So you have 10 Mbps each on DSL. What you want to do is you get a portion of bandwidth for a particular application and you add them all up. So now you take 3 Mbps from DSL1 for the HTTPS and the same amount from the DSL2. You combine them, then you have the 6 Mbps for HTTPS. Okay? Now, the good thing about this configuration is a particular application like a browsing won't consume all the bandwidth because one of the problems with the PCC is its hash algorithm. Sometimes you just don't have the control of how many bandwidth a particular application could use. It could eat up the whole 10 Mbps only for one HTTPS. So what we want is to control for each line, for each DSL, how much a particular application can get. So you're actually guaranteeing that, okay, 3 Mbps HTTP won't consume more than 3 Mbps from DSL1. The same way with the DSL2. All right? As opposed to the other one, which is this. Consumes, take the bandwidth from the other DSL, return it back when it's done. All right? Now, here is an example of the video that I excuse me. All right. Let's start with this. Where's my mouse? Now, look at this. Huh? Sorry. I'm a bit confused. Okay, here. No, I wonder where's the start button. Couldn't find it. Sorry. Now, look at this video here. The local bridge here is the interface attached to your local network, and whatever goes in and out there is only destined to the internet and nothing else. Now, looking at the capacity, I took this video during off-peak time. Now, looking at the local bridge, it reaches 223.1 megabits for the download and 23.9 megabits. Now, on the Q3, if you can see port 1 HTTP is set to 3 Mbps only. That corresponds to the PPO EPLDT. Okay? So that particular application for that particular port won't reach beyond what I assigned it to use. The same way with the port 2, 3, and so on and so forth. Now, looking at the CCR1-Ether11, that is the trunk port. Attached to it is another CCR with 10, 20 Mbps fiber connection. As you can see, it hits 97.3? 97.3. So you add them all up together and you have 221 megabits. And these are all from a DSL. Okay? So you have a control here of how many bandwidth that you can use per each line here. And here's another one. And here is the data game. There you go. See that? So again, I took 3 Mbps speed from each line only for that particular game. It guarantees that game at 3 Mbps speed. No any other application can use the entire speed of a single DSL line because of that. And it gives me a total capacity of 127 megabits for the all lines only for data. And the end result is a lower ping, a faster gaming experience, and no lag. Okay? So with the MikroTik, the most common problem of my client who always asks me how many WANs it can support is no longer an issue because you can expand it to the number of ports you want using the VLAN only. Okay, not unlike with some other how is this? Not unlike with some other off-the-shelf router, you are only limited to 2 WAN ports or 4 WAN ports, and if you want to add some more, then you have to buy another router. Now you ended up with many routers on your shop, in your business, and if one router goes down, then you have to squish all those computers to the other router. Now you have a very congested internet, right? With the MikroTik, it's so scalable that you can add unlimited ports of WAN. Just use the right model, like the CCR series or the RB1100. You can expand up to 100, 200, or even 1,000 WAN ports only by just using the VLAN. Okay? And I don't suggest to do this with doing this with RB2011 or the RB951 because of the mangling rule that you have to deal with. It takes a lot of processing power. So just stay with the CCR or the RB1100 and you can expand your ports to whatever you want. All right? That's it for now. Thank you.